Hello, good afternoon, good morning, wherever you are in the world. So, welcome to another episode of She Builds Tech Skills North America. And today, our guest Sunita Koppar will walk us through an AI landscape very significant, which is inference monitoring and mechanism of our AI/ML pipelines with SageMaker AI and MLFlow. I'm MJ Zilweta, Customer Solutions Manager here at AWS. And for those of you who are watching us live, can you pop in the chat where are you joining us from so we know and we can give you a shout out? But without further ado, I want to introduce to you again our guest, Sunita. Sunita, could you kindly introduce yourself, your background, and share your AI career journey with us today?
Sure. Nice to meet everyone. Thank you. Thank you for having me here, MJ. I'm Sunita Koppar. I'm a senior specialist solutions architect in generative AI and ML at AWS. Been here for about 4 years now. And before this, I've worked at many other Fortune 500 companies, IBM, Sun Microsystems, and Yahoo Horizon, to name a few. So it's been fun journey so far. I started my AI with my previous company, the Edgecast, where we started doing a bit of profitability analysis, and then that took shape into figuring out. Landed in master in data science, and that was my journey. So it's about 5 years since I've been in the AI space, and it's been
Awesome.
fun so far.
Yeah, that's good, and it's very relevant nowadays, especially the skills that you have. A lot of our customers are benefiting with the years of your experience you're sharing with them. So lovely to have you today. So Sunita, maybe we can start talking about what is predictive ML, because I think in one of my posts in LinkedIn, I said like predictive ML is not dead. It's like rock and roll is not dead. So if you could give us like a little bit of, high level overview what a predictive ML is and why is it still relevant, that would be awesome.
This is such a top of mind question, and I kind of keep going back. I also work with students across universities, and I keep telling them, like, it's not dead, you still need it. And there are a lot of use cases where it's very relevant. So, how about we jump to slides just to have a visual
Yeah,
impact of what it looks like? Let's go into
absolutely.
the table that we are looking at, where it kind of gives you a nice breakdown. Let me know when you're ready.
Yep, absolutely. Let me just share my screen real quick. So at least everyone would know what we are talking about.
Absolutely.
Okay. All right.
Yeah, don't worry about reading it. I'm still going to speak to that. The biggest starting point, or why generative AI became such a big thing, is because of the first point there. There is no prerequisite. You get intelligence as a service, you can say, where you just plug in, invoke an API, and you get the understanding, basically, the World Wide Web's data available to you as your inference. That's the number one. Although the predictive ML requires some training. You have to gather your data, you have to put your trainings through it, test them out. So that is the biggest difference. Then what goes on are like particulars of the two. Like generative AI essentially is generating net new content, while predictive ML is kind of doing probability analysis and gives you, okay, this could be it. So a single value prediction typically, or a single category prediction. That is the typical use case for predictive ML. This kind of goes on, like rest of the classification you see are kind of causes of why this is the case. For example, unstructured data is where you would require the generation ability a little more, versus you would operate with tabular data when it comes to the predictive ML side of it. And likewise, there is, I want to also delve upon the output style and some details there. This is the main part which makes it very sticky. The predictive ML side of things. What I mean by predictive ML is the classic logistic regression, XGBoost, and all the other typical things that existed before generative AI. Also, generative AI is also a neural network model. People do not think of it that way. It is just another neural network. That's I would like to say that. What determinism, the predictive ML brings to space is you have things like SHAP, Shapley additive values, as it called, which tells you explanation of why it made a certain prediction. This is a huge research area today with generative AI. when it gives you an output, why exactly it gave you that output or those set of tokens. It is an area of active research because the parameters are just so many. You have billions of parameters. So attributing a specific output back to a ton of other parameters is a bit cumbersome. And work is being done on that. You might see more in near future, but that's what it is today. Likewise, also about how do you figure out what's going on, you would probably ask the model that's giving you an output of why did you give that output. That is the state of the art today with generative AI. And another very important thing is the latency. Generative AI is more expensive and more slower. So the latency is low with predictive ML. You will get like sub millisecond latency, which is possible with predictive ML, and it's in seconds at least with generative AI.
Yeah, and I've noticed that too in generative AI. So, say for example, I'm using a specific model. It really thinks first because my data that I'm asking about is unstructured and it's very open-ended questions sometimes, and it needs time to think. But to your point, in predictive ML, the data is already there, ready to be captured and ready to be utilized by the user. So that's how I see the difference as well. So which is pretty cool. Now, I know a lot of people are, or a lot of us are using generative AI more than predictive ML. So, in terms of like, usage, can you give us like some examples when to use generative AI and when to use the predictive ML?
Definitely. So, in a lot of cases, enterprises do have a ton of data and a historic information available. One part that you can pick from this is structured tabular data. If you have structured tabular data coming in and you have intelligence you have gained over the years, for example, fraud detection. And I'm going to double click on fraud detection just in a bit as we go through our demos. So, fraud detection is a classic case where you would still want to use your own data set, your own tabular data, because there is a lot of specific values like who is the user, where is the user using it, what is the amount. They're all specifics which kind of contribute to your tabular definition. And also you would like kind of if you want to go into details like say cancer prediction, this is another like hello world type of example that you'll see with XGBoost models. So that is another area where you want to know like, okay, you have specifics of tests done on a specific patient, so you have all those values and you have metrics for every reading that you want to rely your analysis on. That is another case. So everything that requires low latency requires explanation of how you arrived at that and is available in a tabular format is the best situation for predictive ML.
Perfect. And before we move forward on our episode today, I want to pop in some questions to our listeners or audience. Like, I want to know like how they use predictive ML in their projects or use cases in their own companies. So, if you have like a specific use case where you use generative AI versus predictive ML, that would be awesome to share with us as well. All right. So I kind of want to double click specifically on, on our topic today. Like, what are the challenges we are solving for with the help of predictive inference meta monitoring?
Absolutely. Thank you. That is a term that I kind of came up with based on everything else. I come from analytics world, so I have this metadata as a thing, and that's how we kind of termed like the term meta monitoring, which is monitoring of monitoring. But before I get to that, let me go through the entire life cycle so we understand why meta monitoring is important. So as you can see on this screen, like we have AI model lifecycle, like throughout from the time you create your model to the deployment. How do you break it down? Now, it's interesting that we already call this classic ML.
Yeah.
I'm just referring to everything that predates generative AI as classic ML. So it includes neural networks or logistic regression, all those kind of models. What you typically do for those is you start preparing your environment. You basically onboard first. I'm referring to the top bar in the screen here. Then you build and train, and then you establish governance over it. Like when would you say a model, a newer version of the model is approved for inference? What I mean by inference is when it's actually used at the time of prediction. then you deploy it, and then you monitor. That's your typical order of things with
Mhm.
predictive ML. With generative AI, although you can do this onboarding and customizing, like fine tuning or continued pre training kind of a thing, where you still can bring your data, you have an option of directly going to invoke and monitor. So that's an option you get when you're using generative AIs.
Yeah.
Um, that having said that, I can go into a little more details into why we're doing it. Let me know if this is the right time, Jay.
Yeah, no, I think it would be good and perfect timing to show it in action, right? Because I know that we will probably have like a couple of use cases or a use case that we want to really dive deep or double click on. And also, you mentioned a word that I'm not very familiar with, SHAP. I will put a pin on it, and I'm pretty sure you're going to show it on to us during your demo. Sounds good?
Absolutely, yes.
Okay.
Yes.
Yeah.
And I have some recent additions also that I did to my repository, which I'll show towards the
Yeah.
end.
So shall we, go ahead and do our demo, or where do
Yes.
we want to? Yeah, okay,
Let's
perfect.
do that. But I do want to take on questions if there are any before I start, because I want to make sure I address it as I go. Do we have any questions from?
Not at the moment, but yeah, I'm pretty sure once you do the demo, there will be a pop of questions there, here and there. Because I am personally, I also have some questions about how monitoring plays a vital role in predictive machine learning. Because sometimes when I hear predictive machine learning, I trust it so much already that I don't really think about the drifts. Or I know it's like a very technical term in machine learning, but when you were explaining this to me when we were preparing for this session, I was like, I had a lot of aha moments that are there are several drifts that we have to account for to make sure that we're giving the most accurate information to our customers and to the users. So
Yes.
would love to know more about that.
Definitely. So
Yeah.
let's do it. I'll start with a high level of what this solution entails, and then we'll go into specifics. And the crux, the meta monitoring piece that we are referring to, is essentially this part. And let me tell you what this diagram is talking about. So, this diagram has the entire architecture of the solution that's being presented. What we start out with this is the training part, where you actually have your own data sets. By the way, this repository has data generation script as well, so you can use the script and generate mock data if you want to just get a hang of it. So you start out with your training jobs, the entire training pipeline, and at the end of it you will have a model ready for inference. What I mean by inference is, when you're actually having your customers, suppose I am a bank, and I have my customers using their cards swipe at point of sale. At the point of sale, when the swipe happens, you need to have a quick prediction whether this is a fraud transaction. Should I approve this or should I deny? You see the spinning wheel that when you swipe at Target or anywhere, that will trigger some process like this.
I
And,
see.
and that will be approved means that it has predicted it not to be a fraud.
Yeah, and I'll give a personal example too. So I was in Amsterdam one vacation, and then one of my credit card companies asked me, "Did you use your credit card in Amsterdam?" Because I forgot to, I tell them that I'm traveling, and it was like quite a big amount because I went shopping. So they gave me, or they texted me and asked like, there is an amount of X number of dollars, is this a valid one? And I was so amazed because it was so quick. Like right after I swiped my card, went out of the store, I got the text right away. So I'm assuming that is the purpose of this, monitoring that you're talking about, right?
Absolutely. And sometimes it does, based on certain, just to have better user experience, the approval goes through. But then there is this post inference analysis that happens, based on which there is a specific threshold that's set. Like if it goes beyond this, then there is a possibility that it could be a fraud. Let me just get confirmation from the user. And that's a very interesting point. I'll come back to it. When
Yeah.
we go to the ground truth piece, remind me if I don't.
Yes.
So this is excellent point. We are done with training. Yeah, as a part of this solution, what we also have is an asynchronous way of making sure we write the inferences to an Athena table. And the reason why we are using Athena table in this parlance is because it gives you a central place to collect all the information. And the fact that we're using something like Athena gives us the ability to then run governance against it. So you're as though collecting central repositories for your data sets as you gather them, and then eventually you'll be able to view them in different with different tools. So that's on the training front. Now, inference monitoring, which actually feeds the majority of our monitoring that we're talking about today, is you generate this ground truth. By the way, generation of ground truth is because this is a mock solution.
Mhm.
In your own, like the bank that we were discussing, the scenario is when the pop up comes to you and you said, yes, it's me, then we got a positive ground truth saying that we got a confirmation. So that is the kind of data that you would expect in a typical business scenario. You gather that, which means you know that a specific inference is fraud or not fraud. You collected that information. So that process is specific to every business. And as a part of this solution, I have scripts which will generate mock data here for you. So once that is done, it gets merged with the inferences that happened. So it gives you like, okay, this was the inference invocation of my model. These were all the input parameters that were sent. I predicted it's a fraud and it's a fraud, or I predicted it's not a fraud and it's not a fraud. It could be other way also. I
Mhm.
predicted it's not fraud, but it ended up being fraud. So that is also a possibility. All that you capture, and then you have like we use something called Evidently AI. That's a third-party open source library, which makes it easier for us to compute drift. What I mean by drift is we started out our processing or creation of our model. I'm using XGBoost here, by the way, but this solution works for any kind of predictive ML model. We started out with training data and we had one kind of training data with us, like we had some rows which had customers of a certain age range. We had customers with a specific credit card limit and their account was available open for some number of days. We had all those attributes in our training data, and when we actually run our inference, when the model is deployed, the data that's gathered may look different. So that is one possibility in drift, which means our data shifted, because then our model was trained to determine what is fraud or not fraud based on those input properties.
Mhm. Yeah.
Now, at runtime, inference time, the input has changed. That might have an impact in how my model will predict. So we monitor drift in two categories. One is the data drift. Second is the model drift. What I mean by model drift is my model used to be 90% accurate. It was 90 times out of 100 identifying fraud correctly. But now I'm only doing it like 70 times out of 100.
Yeah. I love it. Like we said, we're gonna pin another one aside from SHAP. We're gonna pin the data drift and the model drift because
Yeah.
I love those topics. So going back to the differentiation quickly on generative AI and predictive ML, I can clearly see the difference because with predictive ML, the data is already there, like probably inputted by the bank in our use case. Like, hey, you have like a credit score like this, and this is your credit limit, your age is like this, etc., etc. They have like historical information already based on the age and also the credit limit and the usage of the customers. Now, in generative AI, if you don't have RAG or knowledge bases, then your model won't be able to answer those questions like, hey, did if I type something like, did is this a fraud, it will give me a very generic information of like what of card fraud looks like if I don't have the RAG or a source of knowledge base. But to your point earlier, in predictive ML, it's very structured already and it's easier to get the historical information and even forecast it if needed.
Absolutely.
Yeah,
Yes.
perfect.
Absolutely right. And even with RAG, we cannot be sure that it's interpreting the tokens appropriately. Like I'm giving it a tabular data, how properly is it aligning it to my fraud probability? That is still a question mark.
Yeah, and we're not saying generative AI is bad for whatever reason. Not at all. What we're saying is that there are different use cases for different use of our AI or ML models or generative AI versus predictive machine learning. So that's what we're saying here.
Absolutely. And there is no tug of war,
Yeah.
interestingly, between the two. We can use them in combination. Like I can use my predictive ML as a tool with a generative AI, and generative AI piece provides a nice tailored answer. Like if it's an end user asking, why did you flag this as fraud? Then I
Yes.
can attach my generative AI model, which reads this, picks the inference, or whatever result the predictive ML has given, and then give a nice user friendly way to respond to it. So we can use
Yes.
them together.
I love it because it becomes your human based response to the user, not like a technical predictive machine learning output.
Absolutely.
Yeah.
Yes, that's right.
Perfect. Yeah. Cool.
So
So yeah. Sunita, like what do we do next? Are we going to do like a demo right now, or do we have to dive deeper still on the architecture?
I just want to do one more piece and then I'll switch to my demo. It's a pre-run demo, by the way, because
Yeah.
some of these do take time. So I'm gonna walk through. The only last piece that I want to show from architecture perspective is once you have all the drifts computed, you would want to look at it like we can look for a drift between my earlier training data versus what I'm seeing today as a point in time, and I can compare like maybe one or two runs. But what really matters is understanding the drift over time. Like over time, am I seeing, suppose I trained with the data here where my credit limit was say 50K. Now with inflation, credit card companies have increased it to say 500K. Now the data itself has shifted. Is it a permanent shift or was it a blip? Somebody, some data engineer missed adding, like there was some data corruption and then we lost a decimal point or we added a decimal point, and then it became like that is the reason we are seeing a blip for one time. Those things are very important from a governance standpoint. Like somebody who's looking at overall health of the system might want to look at trends, like not a single point in time variance between the training and the inference data, but observe the entire trend.
Mhm.
That's the crux of what we are going to show today, which is going to be a quick side dashboard with all the trends. But let me start from this step,
Yeah.
and I'll
And
walk.
while you're prepping for your demo, for those of you who are listening to us, like I said, if you have like a predictive ML, use case, feel free to share it with us. Or how did you use generative AI and predictive machine learning together? And was it successful? Would love to hear from you. If you have questions, pop it in as well.
Absolutely. Please feel free to stop. Before I start, and is it too small? Can you see this all right?
We can make it bigger, a little bigger. I can see it, but yeah.
Okay. Yeah. How about this?
Yes. Now,
Okay.
before we proceed, can you give us an overview where we are at in the console right now?
Definitely. So I am in SageMaker console, and how I got here is I have this SageMaker setup, and I just opened my studio here. This is how I landed there.
Perfect.
So I am in SageMaker Studio, which is a central place for you to have all your AI work. You have MLFlow in this, which I'm going to show you, and there
Mhm.
is pipelines that I'm going to show you. So let me start out with this is what I did. I have a Jupyter space, and I have the space up already, which I have opened, and that's what this is.
And Sunita, just quickly, for those of the listeners who are new to SageMaker, can you have like a quick overview of what SageMaker is? I know I'm putting you on the spot right now, but yeah.
Then no worries at all. So SageMaker is our AI services set. It gives you everything you need from all the way to of model creation to deployment to monitoring to observability, everything in one place.
Perfect.
That's SageMaker. It has a bunch of services within it. There is something like Jumpstart, which gives you ready to deploy models, generative AI models. And there are a bunch of other things like there is a feature store, there is Data Wrangler, which
Yeah.
gives you easy drag and drop way of adjusting, like processing your data. Then there's also pipelines, and I'm going to show you pipelines right now. So there are a lot of things, and I'm not even using all of them for this solution.
Yeah. Perfect. Thank you.
Okay, let's get into the training part. So as I was referring to in the three blocks that we had, there is a training step, then there is an inference step, and then there is a governance step. So as I promised, I'll go to SHAP towards the end if time permits. If not, I'll leave you with all the resources. So this is a training part. I'm You don't have to read this. You can refer to GitHub later. Let me go through the entire process here. So I trigger the training job here. And at the end of the training, let's actually go to the pipelines. I have it here. Yeah. So this is my training job, which I invoked from my notebook. By the way, I can also invoke it from my IDE locally on my laptop.
Perfect. Yeah.
I clone it locally and run it too, which is my preferred way in most cases. So when I leave the agent running on cloud, that's where I use notebooks on SageMaker. Otherwise, I use it in my IDE if I'm testing live. So I use both. So this is my execution of the pipeline. As you can see, there is a pre-process step, then there is a training. This is the actual XGBoost training. There is an evaluation step. All these are configured as SageMaker pipeline steps. And what you're seeing here is a SageMaker pipeline, which gives you like a workflow look of the training stage of the entire pipeline.
Perfect. Yeah. It's like the sequential flow of the process or the workflow, right?
Correct. Yes, that's right. And once you evaluate the model, you can check for the quality, and then finally you will register the model. So when it's registered, it becomes available for governance and viewing as a model itself. So we'll look at that. And after you do all the tests, if it does not go to fail, which means the model is good, performing well, you will end up deploying the model. So this is when it's ready for inference. Now, once it's ready for inference, you will probably be having multiple transactions, multiple invocations for that model. And that data gets collected in your Athena tables. Now, let's look at what kind of metrics you can run. So, this is, by the way, end to end automated as well. And
Yeah.
let's go to, I kind of gave you a sneak peek on SHAP already.
Yeah. I was gonna ask that later, but I can wait.
Yes, yes. Let's wait because it's going to go deeper into one specific aspect. So
Yes.
it's probably best for later. So this is what I wanted to show you on the data drift part. So how did we come to this? In our second part there in our architecture, as we were looking at the inference path, in the inference path, you can do an on-demand trigger. Like I have collected, say, 100 inferences, 100 card transactions happened today, and I have all that data. Now tell me, do you see data drift in it? I may or may not have collected ground truth. What I mean by ground truth is, was it actually fraud or was it not fraud? That is my ground truth. I may not have collected that, but I at least have the inference already.
Mhm.
So with that, I can still do my data drift. Data drift does not require ground truth.
I see.
And
Yeah.
what is data drift? Now you can see here, for
Yes. I
example,
was gonna ask. Yeah.
yes, you can see that. So you see some shift here. Like the green is what the reference data is. What was the data trained on? That is green. And what you see in red is the spike, which shows it looks different. You
Mhm.
trained on some value, but now the value that's coming in with your inference is looking different. It also shows this in data drift like this as well, like a data distribution chart. This is what evidently gives a lot of this out of bat. You just give it your training data set and you give it your new data set. It does this comparison and gives you these nice interactive dashboards. You can look at a lot of these, like it'll show you shift in the trends. It'll also say, for example, in age, it'll
Yeah.
show you some variance.
Yes. So in our use case on the credit card information, so say I'm not gonna give my age range, right? But like, hypothetically, how can you use data drift, or how can you identify data drift in terms of the credit card use case that we have? I almost said my age, which I don't want to. So
You look like a teen, so definitely doesn't matter what your age is. Um, so, how would you interpret this? Is like, suppose I trained my data and my reference age range for my training data was like, say, 20 to 30 years.
yeah.
Those who were spending or using the transactions or creating the transactions were in that age range for my training data set. What I'm noticing in my inference is the fluctuation is a lot wider, which means I have much younger, say 15 plus, all the way going into 50, 60 age range. So I
Mhm.
have my inference data spread out. By the way, these charts look really bad because I've fabricated it. I've
Yeah.
deliberately shown the drift, so it'll look bad. But usually, this is not the case. If you're trained and if you're done your data gathering well, it wouldn't be so spiky.
Yeah.
They They should and they would ideally be in the reference range, at least as soon as you train your model. Eventually they'll shift for sure, because things change, your customer base changes, their behavior changes,
I was gonna say.
dynamics change around, like credit limits may increase. So with all that, you may have more online transactions, so many changes might happen. That is where you will start noticing spike over time.
I see. Like, say for example, this summer, if a credit card company says like we're opening our no annual year, fee for our credit card users between 18 to 25, and then all of a sudden you will see a spike there, which can be categorized as data drift. Is that correct?
Absolutely,
Okay,
yes. That
perfect.
will lead to data drift, yes.
Awesome. Cool,
And
cool.
likewise on model drift, although the model drift part is something that will require ground truth. Because what does model drift mean? Like my earlier model was predicting all the like all the true positives. Like it was predicted as fraud and it was actually a fraud, is a
Mhm.
true positive. It was predicted as fraud, but it wasn't fraud. That will be like false negative kind of. So all those scenarios you will get, and you'll get a confusion matrix created for you, which kind of shows you like how it used to be before versus how it is now. So
Mhm.
precision is, it identified how many of the positives that it recognized were actually positive, and recall is like how many all the true positives, like how many all fraud cases did it recognize. That's the crux of it. I always mix up F and T, and if you look at it that way. So this is my how I would like to present it. And that plotted in a confusion matrix tells you how your model is continuing to work. So to understand, it was predicted as this, but it was actually this, the actually this part is where you need the ground truth.
I
And
see.
that scoring tells you like your when I trained my model, it was at 98 accuracy, and now it has dropped to 87, which means my model is not doing as good a job as when I had trained it.
Yeah, yeah. And what do you do with that when you all of a sudden see a data, oh, sorry, a model drift?
So that is a decision that the say, data scientist would make. Like
Yeah.
there are different ways we can go about it.
Mhm.
It's not that when a model stops, like drops to a certain level, you would immediately retrain. That's a decision
Mhm.
you would make, saying, okay, this is an acceptable drop for me. I'm fine. I can. I have business processes to work around this, because the trigger that you got, did you really do the transaction? That
Mhm.
is a business process that I have set up, so that even if I incorrectly identified something as fraud, I have a way to correct and make it go through.
Yeah, yeah. Perfect. And you don't have to always retrain. Sometimes you just have to like investigate first. And I'm assuming the data scientists or whoever built the capability have a certain threshold. What they say is, oh,
Yes.
this is like becoming inaccurate.
Yes.
It's like only 90% accurate or whatsoever. And then that's the threshold to double check like what's happening behind. Um,
That's yes, you're absolutely right. And that leads to what I actually wanted to show. The crux of today's discussion
yeah.
is the meta monitoring part.
Perfect.
Because absolutely, as you said, we want to know when to retrain, but then we also want to know, was it a one time shift? Was it like a blip that happened only that one day when the systems were down or something? Or is it something that we're noticing as a trend? So this diagram that you see here, let me make it bigger, will show you like this is a quick site dashboard, by the way, which is reading off of Athena, the table that we collected information into. That is this. And what it shows is like specifically credit card limit
Mhm.
has been drifting a lot and drifting sort of consistently. It's been higher for a very long time. And this is the other one where probably this is pin used that has been drifting, or merchant code, I guess. And it's showing you drift analysis over a period of time for the data set that you used. And likewise, you can do like trend analysis of this overall, how it looks. Yeah, all your say 20 attributes or 29 attributes we have for this particular use case. So it's going to show you how many of them changed and what is the frequency in which they're changing. And QuickSight has a lot of benefit, like you can change it and change the kind of
Mhm.
aggregation you have on all of these values. You can go all the way into the individual data set also. Like you can even look at what the actual inference was and what were the input features. You can look at all of them in a single place. So you can see here, this was
Yeah.
predicted as not fraud, ground truth happened to be not fraud. This was predicted as not fraud, but ground truth actually was fraud. So
Awesome. And this is the capability that you built with your team, right? Like the monitoring itself. This is awesome. And I hope we would be able to share this how you put this together later towards the end of our session.
yes, definitely.
Yeah.
I have easy ways to show you that. And yes, let me know when we are ready for that, and I'll explain the whole setup.
Yes. Okay. No, I want to go back. See, like I always forget too what I said I will pin on. So we already discussed the data drift and then the model drift. Is this the best timing to discuss SHAP? SHAP?
Yes, yes, I know.
Yeah.
And I can totally see why. I love it too, because Shapley additive values is what it's called. What it
Okay.
actually gives us, let me open it here in my notebook.
The
And
SHAP stands for an acronym or like what does that stands for?
it is, yeah, yeah, it's Shapley additive explanations. That is the acronym.
Oh, perfect. Yeah.
Yes. And what it actually gives you is a reasoning or kind of explainability into why a certain prediction was made. If
Mhm.
for an input transaction it was called a fraud, then why was it called a fraud? That kind. And how you employ SHAP is again a business process decision. You can say for everything that's labeled as fraud, I want to run SHAP. You can do that. Or you can say for all my predictions, I want to run SHAP. So one thing to note is SHAP is best not done as part of your inference. It's a
Mhm.
post inference process. What I mean by that is you do not want to do your SHAP analysis when the transaction is happening. Let that go through, and you have your other processes to capture ground truth, which you're doing already. SHAP is typically done for auditing perspective, or you want to know, like, say, loan processing. You say decided that this person is not eligible for loan,
Yeah.
then you might be questioned why. Why do you think he's not eligible?
I
Is there a
see.
bias? So for that, you want to make sure you are able to identify and say, this is why.
Yeah.
So that's a very interesting thing. We saw a lot of
Yeah.
in credit limit, right, and customer age
Yes.
range. Now let's go look at. Let me see if the chart shows.
So Sunita, quickly, we have a question from Pankaj 875.
Okay.
What tool is it? I think they are referring to the ML flow earlier,
Okay.
and also the quick. So we showed earlier SageMaker,
Yep.
ML flow, and then the dashboards. This one is quick.
Yes, this is
Um,
Amazon.
yeah, Amazon Quick. And then the other one that you were showing earlier, this one,
Yes.
MLO. Perfect.
MLFlow. Yes. And MLFlow is fully integrated serverless here. If you see, if you log into your SageMaker Studio, you will see MLFlow here.
Yeah,
And that's pretty much what I have. I have this set up here and open MLflow. That's what I did, which is this part, which is this that shows up.
perfect. Thank you.
I'll just show all the tools because I know I'm referring to two, three tools here. The meta monitoring dashboard is in Quick. The MLflow is the open source MLflow, which has been integrated and made available as a serverless offering within SageMaker. This is the second one. And the third tool, which is doing this automatic computation for us, is Evidently AI.
Mhm.
And the links are available in the GitHub repository also. So those are the
Yeah.
three tools that we have gone over already.
Yeah, and maybe we can pop in the GitHub repository at some point. So,
Yes,
yeah,
for sure. Yes. And that will be our takeaway. I'll definitely leave the audience with that. Continuing on SHAP, what this shows is feature importance of all the features, which shows interestingly account age days, which was not showing up in our earlier charts, which shows this is the most deterministic factor. Like a lot of times, account age days decides whether a transaction is a fraud or not, and what kind of impact it has. There must be another chart for me to show you, which gives you like a very nice positive in direction. There's one more. Give me 1 second
yeah,
here. So it shows older the account, less likely it is to be a fraud. So that is the direction of the blue arrows. It
mhm,
shows it's leading towards no fraud. And for example, transaction R is leading towards positive, like it's more likely to make it a fraud.
Mhm.
So this is the benefit that you get of SHAP analysis, which gives you confidence in the predictions. And this is a specific feature of predictive ML. We do not have, as of today, any mechanism to do this kind of drill down into generative AI.
Yeah, perfect.
Are we at a good point to switch to the GitHub repository, or do we want to go into any other drill downs? I would love to hear more questions from the
Mhm.
audience.
So far, we don't have any questions, but yeah, we can switch to our GitHub. So we'll pop the link now. So,
Thank you. And this actually, let me start out here. There is a README that you can refer, which has like, this is the README that we are looking at right now. It has all the steps of how you should get started. If you do not have any exposure to SageMaker, you have never used SageMaker domain, then I would suggest going with option A. What option A has is a cloud formation template, and this builds the entire stack for you. Like, it'll build you the domain, it'll build, put the right security groups, it'll create your VPC routing, everything, so that you have your GitHub clone working. It also sets up the MLflow tracking server, the MLflow that we were looking at, and it creates a Jupyter space for you, which is what we looked at earlier, which we opened to get to our notebooks. This CloudFormation template creates that for you, and it also does a clone. So as soon as you open your Jupyter space, like run the Jupyter space, you will have your entire GitHub repository, this repository, cloned and ready to use. After that, you can just run through cells and you will have the solution working.
perfect. Yeah. And for those who are listening, I mean, this is a good, a good I posted the repository, and this is a good way to, go through this with us. And you can use the concept and the principle to your own use cases. So go ahead and grab that link, open it, and yeah, let us know what you think.
And if there's nothing else that you can take away, the thing that you would want to remember with this is essentially this diagram. Like, I'd like to spend a little bit of time on this.
Yep.
Training has been around, and tracking training metrics is the first thing data scientists do. So you will always track, and MLflow is tool of choice for, so a lot of data scientists are already aware of it. Where MLflow is not used as much as it could be is in the inference landscape. So that is what this solution fixes. Like, here it's focusing now on the inference part of it, the inference segment that we were talking about, and the governance aspect as well. So this is where you deploy your model, your endpoint is ready, and it is available whenever there is an invocation, whenever there is an inference request. It gets tracked and it gets written to this Athena table, inference responses. By the way, we are using Iceberg format, which is a very popular, it's an open source format, Apache format, to make sure you have ACID compliance, like data remains like single source of truth, a single version of the table, all that nice things. That's your inference. This is your training data that you started with, and you use a way to compute your drift. Also, there are two modes in Notebook. When you run, you will see you have a Lambda drift monitoring, which is Docker container based Lambda setup, which does this computation for you in an automated way. So you can configure it through Event Bridge to say, right now the default setting is 2 a.m. daily, but if your volume is too high, you can make it hourly runs. If it is too low, or if you want to wait until you gather enough inference requests, you can make it weekly, however you want to tweak it. This Lambda does the computation and logs the data to MLflow. MLflow has way of comparing like 2 3 runs. You can compare them and look at how the trends are. For long-term drift comparison and long-term model performance comparison, you can also write all of them into Athena, which you will then be looking at QuickSight for
Perfect.
comparison. You can also configure alerts so that if you're getting like a lot of drift, this is the retraining part, MJ, that you were talking about. You
Yeah.
can specify what kind of level you want to hit when you want to alert, and this might be the trigger for you to consider retraining. You have an option to automate everything again. Like the moment there is a trigger, instead of sending it to humans, you can send it to the retraining pipeline, which triggers the SageMaker training path as well.
Mhm.
Generally, customers prefer to do this because when something drifts so much, they want to see what happened before
Yeah.
they just go and plug the new data and let it retrain.
Yeah, because to your point, sometimes it's like human initiated error that causes it. You don't have to retrain it, so it's very costly to retrain than just like investigate what went wrong first. So yeah, I'm
Absolutely.
probably saying the obvious, but just sharing. So
No, that's absolutely right. Yes.
yeah, perfect. This is great stuff. All right. Yeah. Anything more that we want to discuss on the GitHub? I think everything that you have showed on today's session is all in the GitHub information. And if they want to know more about this, are you okay if I share your LinkedIn LinkedIn
Fine.
URL so everyone can can go ahead and connect with you if they have any questions or connect with your team.
Sure. Yeah. To drop in, I will do my best. I'm not great with like social media, so I'll try my best. But yeah, you can definitely follow me because I do plan to put in more assets around the same repository. So you will keep follow like getting the updates if you just follow. I'll do my best to connect as well. Uh,
Yes.
yeah.
And each of our customers have account teams as well that they connect with. So apart from Sunita, AWS has like a lot of SMEs or subject matter experts you can reach out to, but obviously Sunita is one of the best. So
Oh, that's really sweet. I should buy you coffee, MJ.
yes, I think so. I hope you had a wonderful Mother's Day, by the way. So
Yes, I had a great one. Thank you. Hope you had
yes,
one too.
yes, I did. All right.
Perfect.
Okay. So yeah, Sunita, I think anything else you want to cover on on predictive inference meta monitoring? By the way, why is it meta or meta?
Yeah, so nothing to do with Meta as a company. Meta monitoring is the term that we use, like it's a very common suffix, prefix rather, that we use to say something higher at a higher dimension. So, for example, we say metacognition, which is thinking about thinking. So likewise, we call metaphysics, which is physics about physics, something like that. So that is why meta monitoring is like monitoring of the monitoring. You want to look at monitoring at a much larger landscape and want to observe the trends of monitoring runs. So that is the reason I came up with the term.
Yeah,
Uh,
I
I
love it.
hope it communicates because instead of putting an entire phrase to explain what I'm trying to do, like capture drift metrics, model and data drift trends, that is otherwise going to be the default phrase.
Yeah,
Making it meta monitoring makes it easier and communicates the idea, is the thought.
I see. Okay, it makes sense now to me. So Sunita, before we wrap up today, I'm pretty sure there are some people out there, young or those who are shifting careers or whatsoever. How can they get into an AIML sort of like career path? How do you mind sharing like how you started? Is it like your discipline when you were in college, or how did you jump in? Just for everyone to get inspired to get into this career path as well.
Definitely. Yeah. We can maybe stop sharing. I'm done with
Yeah.
the presentation. And yes, we can. And I would love to hear questions also from the
Yes.
audience on this. So I'll tell you my journey. And by the way, I'm learning too. It's exploding every day, and there's so much of content. I still feel like there's lots to learn, and there are great engineers within AWS that I learn from as well. My thought is this: we have these AI tools now, which we did not have before. This is a double edged sword. This could make us lazy and make us not learn. On the other side, if we use it right, it can make us much smarter. And I'll tell you one trick I use. When I do not know something, I ask the AI, what is this? And the moment it gives a response, I start asking, why this? And then I put my explanation, is this why? And then I get a response whether it says it's correct or not. Although, of course, there is scope for hallucination, definitely bear that in mind. So you have to engage with the AI rather than blindly copying.
Mhm.
So what we do is, yes, there is a lot of code generation possibility. There is a very simple thing like in Kiro, there is this button follow that we can click.
Yes.
So as it generates the code, follow what it's doing. You will be amazed at how much you'll learn with
Mhm.
a single project.
Yep.
So that those are my tricks. Those are the recent tricks. Although I did not start that way, I did a little more structured learning. Like I went to the data science course and I did my master's in data science. So that was a starting point. There are a lot of tools available today. To get started, this is the lowest, like the lowest barrier to entry. Be honest with yourself. If you don't know, don't stop until you actually know it,
Mhm.
and that is a starting point.
Agree. No, I love that. It's very, it's very doable. It's not like take the certification right away or whatsoever. It's like experimenting until you are more comfortable of like doing it. And, fail fast, right? Like if you create like a capability, it doesn't impact operations, and then learn from it and then iterate from it. So love it. Cool, cool. You know what? This is one of the episodes that I really enjoyed because it's very fluid and whatnot. And you're the expert on this area. So thank you so much again, Sunita, for being with us today. And for those of you who are listening, please stay tuned again for another episode of She Builds in a couple of weeks. And thank you so much and have a wonderful week ahead.
Thank you so much, MJ, for being the amazing host you are. And yeah, I'm sure you'll be the AI expert next. I can see
I
all
hope
your
so.
sentence. You're already there.
Yeah. And for those of you who want to follow me, please follow me at Miss MJ, uh, Mary Jane Lola in LinkedIn. All right. Well, thank you so much. Have a wonderful day ahead. Bye bye.